Good morning. I was asked to be part of the discussion, which didn't imply a formal presentation. So what I have here is not a very formal presentation. It's just items for discussion related to the two questions that were posed, which is discussing the site-to-site variability and what are the ranges of ES2S variability in the model. So I'm going to skip over some slides because I only want to keep it to the slides that are very relevant. Linda has shown this slide already. This looks at the VSS that we obtained using the Pegasus refinement project data. Here is California. The values here for California are slightly higher than the values elsewhere, and this is consistent. These are consistent actually with the values that Linda is getting. This is using Brian's and Bob's small magnitude earthquake data. If I look at the VS2S values in Japan, this is also the Pegasus data, which is KickNet records up to 2004. These are the site-to-site variability in Japan. It is period dependent. We see the bump that was talked about on the first day, where we have a significant bump at a period of 0.1. I didn't have data in this subset, in the Pegasus subset, at lower periods, but I'm going to show another set of data where we look at a wider range of periods shortly. These bands are the statistical uncertainty of these values. So if one of the questions was specifically site-to-site variability and the ranges of these values, so here you have a statistical uncertainty of these values. There is some uncertainty, but it's relatively small.
What's magnitude range?
This magnitude range is from 4 to 7. One of the reasons for the variability of ES2S is maybe site terms or site effects. So correlation with site parameters. So this I'm plotting here for the Pegasus data all the site terms as a function of VS30 for California, Taiwan, and Japan. And then I beam this into VS30 beams and look at the variability. And you can see that the site-to-site variability in this data in California is not a strong function of VS30 at neither of these sites, neither Taiwan nor Japan. This is for PGA. If we go to other periods, so this is 0.3, you start seeing some dependency, but it is opposite, goes in opposite directions for California than it does for Japan. You don't see something that's systematically in Taiwan. And if I go to 1 second, then you still see this strong dependency. The site-to-site variability is lower for very stiff sites than it is for soft sites. And again, in California, it's the opposite effect. And this is, this is the data. Something I wanted to highlight, that this site-to-site variability has two components, and we can decompose this in the KickNet data because we have surface and borehole records. Unfortunately, I didn't look at the site-to-site variability in the borehole record itself. In this plot, I only have the site-to-site variability in the amplification, that is the empirical amplification or the instrumental amplification we get from getting the ratio of surface to borehole records, and it is a large component of the overall site-to-site variability. I have a student who recently, and this is something that she sent me yesterday, her name Manisha Rai, is looking at site-to-site variability in the NGA2 data. And this is within the context of a study that's looking at topographic amplifications. And you're not interested in topographic amplifications, so I will not highlight that. But this is the site-to-site variability that we are getting for the NGA data. This is pulling together all regions. This is looking at all the NGA data. As a sideline, I can indicate here that there is this is the difference when you introduce topographic effects. But what's more interesting is when we look at the site-to-site variability now, where I'm dividing all the stations into stations that are either on top of ridges or high-lying, low-lying, or intermediate. And I do that with a parametrization that's relatively simple. And what is interesting is that the site-to-site variability will be different for sites that are on a topographic region, this is high-lying, or low-lying, versus compared to those that are in flat regions. Okay, so your site-to-site variability, it is likely to be a function of site parameters, whether it is VS30.
So that's going to impact our ability to calculate a good average. I forgot what Gabe was saying. You used some other word. It was less informative, right? The more variability that is.
Yes.
So if I'm up on your high ridges, I'm going to need more recordings to get a good estimate of the site turn.
That's
right?
correct.
Okay.
Yes. And if you trust this data for California, and Linda will be able to get better data, the site-to-site variability also gets worse for stiffer sites, which is opposite of what we are getting for Japan.
Wait, can we?
Oh.
Am I on? Sorry, can you go back one slide, please? Okay, on here you have the high is high, the low is sort of in the middle area, and then the intermediate is lower than the intermediate. Can you kind of explain why the intermediate would not be between the high and the low?
No, the intermediate is a flat site.
Okay.
So you can think of the intermediate as being one that has no topographic effects, whereas the low-lying, it has topographic effects, it just happens to be lying low in topography. The high-lying, it has topographic effects, but it will be lying high on topography. So physically, I think there are reasons as to why you could think that sites that are in topographic accidents will have more site-to-site variability, because I think they're going to be their response is going to be azimuthal dependent. There's going to be much more dependent on frequency content of the input, on the input motions, whereas sites that are relatively flat will have less of this effect. So I think this makes intuitive sense.
Okay, sorry, it just got confusing.
So the low, is it like a basin or a valley that we're kind of
Yes,
talking about?
those that are low will either be in canyons or in valleys.
Okay.
This is, you can see, I didn't show this because this was not part of what we're looking at, but you can see differences in the site terms as well. The sites that are high are biased high somewhat. The highs that are low are biased low, but it's only a band-limited effect. It's not over all periods.
Yeah, just a quick comment. One possible explanation for all that is that if the topography is variable, you probably have 3D effects and who knows what down below.
Adrian, I know you suppose, I know you have other project on topographic effects. Have you compared these with anything else? You have some recordings in Utah, I believe. Is that right?
Yeah. This is part of a larger project where we are looking at topographic effects in the centrifuge and other. And the
How does
results,
it compare?
The results are actually comparable.
Okay.
But we're looking, it's very different phenomena, so that's a whole other presentation. But the results are generally comparable.
Okay.
If you go, part of what you're working on was updating the Japan VSSs. And do you have what you consider an update or even an indication of how those results are going?
Not now, but very soon.
Okay.
And we did look at only Tohoku aftershocks, and this is published already in the SSA, and the results are similar. And that's where we looked at the gridded, looking at single pattern, the grid effect. So the results are not significantly different. But looking at the whole data, we are right now running regressions for shallow crustal earthquakes, so we'll have those results relatively soon. And the biggest change is not just that we added much more data, but looking much more carefully at the metadata. And that actually, we had really large taus in our original study. I think those will go down.
That's somewhat like what Sinan was implying, right? If you isolated the stations or events with better metadata, then your taus would be coming back down. Is that, or your
That's
feed?
that's what I would like to do.
Okay.
So that's work in progress, but we have already a flat file, which is the most difficult part, and we are right now running the regression. So So the summary of VS2S, there are stronger regional dependency than VSS. There may be VS30 dependency or some additional site dependency, for example, topographic effects in some data sets. I added a couple of slides on the bump that was discussed, and these are actually slides that I have already shown, but I can focus here. Look at the very high total sigmas that we have in Japan. This is with up to 2004, KickNet data up to 2004. And here I have additional periods. It's the same data I showed before, but with additional periods. And you can see the bump at 0.1 seconds. This is surface data. If you look only at borehole data, and this is ergodic sigma, the bump, there is a smaller bump. Smaller in the sense that the difference between a period independent and the bump at some frequencies is smaller, but happens at higher frequencies, not at 0.1 seconds. And if we look at borehole, single station, this tends to disappear. There is still a small effect, but in general it is smaller. I think this goes to support what Bob was saying yesterday. This is the same thing. Okay. This is what I was charged. I have additional slides, but